Hello, I'm Rahul Baghel, Assistant Professor, Chhattisgarh Swami Vivekanand Technical University, Bhilai. Welcome you all to the course Industrial Automation and Drive. Today, we begin with our first lecture focusing on overview of electrical system in industrial automation. In this lecture, we cover the following topics. The first one, introduction of industrial automation. Second one, overview of electrical system in industrial automation. The third one, integration of electrical system in industrial automation. So let's start the lecture with the first topic, introduction of industrial automation. The word industrial automation made with the two words industrial and automation. And industry is a branch of economic activity focused on the large scale production of goods and services. It typically involves the use of machinery, factories, and advanced technologies to convert raw material into the finished product or to provide a specialized service, such as in manufacturing, construction, or energy productions. The word automation is derived from the Greek word auto and metos. Auto means self and metos means moving. So automation is a mechanism for the systems that moves by itself. However, apart from this original sense of the word, automated system is also achieve significantly superior performance than what is possible with the manual system in terms of power, precision, and the speed of operation. In a simple word, industrial automation means using computer, robots, and technology to control machinery and processes in factories. This reduces the need of human involvement and improves the efficiency, productivity, and the safety in manufacturing. Now let's talk about the key component of the industrial automations. The key components are control devices, sensors, actuators, specialized software, robotics, network communications. So let's start with the first topic, that is control devices. These devices play a crucial role managing and regulating industrial process. They include PLC, that is programmable logic controller, DCS, distributed control systems, and the other specialized controllers. And the second one is sensor. The sensors are the eye and the ears of industrial automation. They collect data from the environment such as temperature, pressure, humidity, and positions, and provide the real-time feedback to the control systems. Example include proximity sensors, temperature sensors, and the photovoltaic sensors. The third one is actuators. Actuators are responsible for the physical actions based on the control signals. They convert electrical signal into the mechanical motions. Common type of actuators include electrical motors, pneumatic cylinders, and hydraulic actuators. The fourth point is specialized software. Industrial automation relies on a software solutions tailored for a specific task. This includes HMIs, that is human machine interface, SCADA, that is supervised control and data acquisition system, and industrial communication protocols. SCADA system monitors and control processes across the large scale facilities. Now next, talking about the robotics. Robots are the integral part of modern industrial automations. They perform repetitive tasks with precision, speed, and consistency. Industrial robots handle tasks like welding, assembling, material handling, and the painting. Collaborative robots, cobots, works alongside human enhancing safety and efficiency. Now, the last topic is communication network. Communication network connect the various components within an industrial system. Ethernet, field bus, protocols such as Profibus or Modbus, and the wireless networks enable seamless data exchange between the sensors, controllers, and the other devices. In this lecture, I just provide the brief idea about the key components of industrial automation. Deep and detailed discussion about the key components we will cover on the upcoming lecture number 8. Now let's talk about the electrical system in industrial automation. Electrical systems are the backbone of industrial automation, providing the power and control necessary to drive automated process. These systems include various electrical components and technologies that works together to ensure smooth and efficient operations. The key component of electrical system in industrial automations are: first one is power supply and distribution, second one is motor and drives, third one is control systems, fourth one instrumentation and measurement, fifth one wiring and cabling, sixth one control panels, seventh one grounding and bounding, eighth one protective devices, ninth one power quality management, 10th one energy management system, that is EMS. So let's start the first point, that is power supply and distribution. The power supply and distribution system is fundamental to industrial automation, ensuring that all the machinery and processes receive the necessary power to operate efficiently and reliably. This involves a network of components designed to manage, distribute, and protect electrical power from its source to the point of use. Main components are transformer, switchgear, distribution panel, busbar and distribution boards, power supply units, power conditioners, wiring and cablings, grounding and boundings, power distribution units, surge protection devices, that is SPDs. So let's start the first one, that is transformer. Transformer transform voltage level to meet the requirements of various components in the automation systems. On the basis of voltage level, there are mainly two types: step up transformer and the step down transformer. Step up transformer increase the voltage from lower level to the higher level, typically used in scenario where the power needed to be transmitted over the long distance to reduce energy loss. Step down transformer decrease high voltage to the lower level, suitable for industrial equipment and machinery. These are commonly found in facilities where incoming power needs to be adjusted for the local uses. Now next one is switchgear. Switchgear is a fundamental component in industrial automation, responsible for managing the switching, protection and isolation of electrical circuit to ensure the safe and efficient operation of the electrical systems. Circuit breakers are the vital within this setup, automatically disconnecting power to the protect the systems from the damage during overloads or short circuits. This safeguarding action holds the current flow, thereby protecting the network and the connected equipments. Switches play a crucial role by enabling both manual and automated control over the connections and disconnection of electrical circuit, essential for facilitating maintenance and isolating faults within the systems. Additionally, relays, which are electrically operated switches, are crucial in the automation process, controlling high power circuit using low power signal. This capability allows the flow of efficient management of multiple devices through a single input. Together, this component of switchgears ensure that industrial system operate reliably and efficiently. Distributed panels are essential component in the industrial settings, serving to centralize the distribution of electrical power across various component and subsystems. The main distribution panels act as a hub, receiving power from the main supply and subsequently distributing the different sub-panels or directly to the load within the facilities. These panels are equipped with the circuit breakers and the protective devices to ensure safe and efficient distributions. Sub-distribution panels play a crucial role by further allocating power from MDPs to specific areas or machines, offering localized control and distributions. This segment of electrical load simplifies management in large facilities, enhancing operational efficiency. Next is control panel, is another integral part, consolidate, divert electrical and electronic component such as relay, contactors and the PLCs, that is programmable logic controllers. They serve as a centralized enclosure for monitoring and controlling the automation system, facilitating seamless operation and maintenance across the industrial environment. Now let's talk about the bus bar and distribution boards. Bus bar consists of metal bars or strips that serve the conductor, efficiently transmitting electricity to different segments of automation systems. They are specifically energized to handle high current with minimizing energy losses, offering a structured and effective method of power distributions. Next one is distribution boards. Distribution boards, on the other hand, act as a centralized enclosure housing essential circuit protections devices such as fuse and circuit breakers. These boards organize and manage connection to various parts of systems, ensuring the safe and efficient operation of electrical circuit. Together, bus bar and the distribution boards play a crucial role in maintaining reliable power distribution and facilitating streamlined connectivity across the industrial environment. Next one is power supply units, that is PSU, are crucial components in industrial automation, tasked with converting the regulating power to meet the precise requirement of automation components. AC and DC power supplies play a central role by converting alternating current sourced from the power grid into the direct current, which is essential for powering most electronic devices within automation system. Regulated power supply ensure a consistent output voltage independent or fluctuation in input voltage or load conditions, thereby stabilizing sensitive electronic component. Now let's talk about the uninterruptible power supply, that is UPS, are the essential safeguard in industrial automation designed to provide backup power and protect against interruptions to ensure continuous operation of critical systems. Online UPS system operate by continuously delivering power from their inverters, offering seamless protections within no transfer time during power outage. This design ensures the highest level of reliability for vital equipment. Offline or standby UPS systems keep their battery and invert on standby, activating battery power only when an interruption occurs. This design is ideal for application where uninterrupted operation is less critical. Collectively, UPS variants play a vital role in maintaining uptime and protecting sensitivity equipment from power fluctuation, ensuring a smooth and reliable operation in industrial environment. Now let's talk about the power conditioners. Power conditioners are essential component in industrial setting dedicated to ensure the stable and reliable power supply to sensitive equipment. Under this, voltage stabilizer are integral in this role, maintaining consistent voltage level to protect equipment from fluctuation that could otherwise cause damage or operational disruption. Next one is surge protectors provide a critical defense by shielding electrical devices from sudden voltage spike and transient which may result from lightning strike or switching surge, thereby safeguarding against potential damage. Power filters. Power filter play a crucial role in enhancing power quality by eliminating electrical noises and interface from their supply, ensuring that sensitivity electronics receive clean and stable power. Together, these components of power conditioner contribute significantly to the longevity and optimal performance of industrial automation system by mitigating risk associated with the power variance and the disturbance. High voltage cable play a crucial role in transporting substantial electrical current from transformer to distribution panel and the large machinery, ensuring efficient power distribution across the facility. Conversely, low voltage cable are essential for connecting control system, sensors and a smaller equipment that operate at the lower power level, facilitating precise control and monitoring within the automation system. Shielded cable provide essential protection against the electromagnetic interference, that is EMI, maintaining the integrity of signal transmission in noisy industrial environment and ensuring accurate communication between devices. Together, these components of wiring and cabling from the backbone of industrial automation infrastructure, enabling reliable operation and seamless connectivity across the diverse industrial application. Now let's talk about the grounding and bounding, ensuring safety and minimizing electrical interference within industrial automation system. First one is grounding system. Establish a reference point for the electrical circuit and provide a path for the fault current, reducing the risk of electrical shock and ensuring safe operation. Bounding conductor electrically connect all metallic parts to maintain uniform potential, further reducing shock hazard and minimizing interference between components. Now let's talk about the PDUs, that is power distribution unit, play a pivotal role in distributing electrical power to various devices and systems within the advanced monitoring and control capabilities. Under this, basic PDUs distribute power without additional features suitable for less complex applications. And next one is metered PDUs offer real-time monitoring of power uses and load levels, aiding in optimizing power distribution and managing energy consumptions efficiently. Next one is switched PDUs, allows remote on-off switching of individual outlets, offering flexible control over connected devices commonly used in data centers and network operations. Next one is surge protection devices, that is SPDs, safeguarding electrical systems from the transient over voltages that can damage equipments. Under this, type 1 SPDs are installed at the main service entrance to protect against high energy surge from external sources like lightning strikes. And the second type of is type 2 SPDs are positioned downstream of the main panel to shield against residual lightning energy and internally generated surge from switching activities. Next one is the type 3 SPDs offer localized protection for sensitive devices against surge attenuated by upstream SPDs typically installed close to the equipment they protect. Now let's talk about the second point, motors and drives. Motor and drives are integral component within electrical system in industrial automation, serving to convert electrical energy into mechanical motion with precise control and efficiency. Electric motor act as a primary power source, transforming electrical energy into rotational mechanical energy. They come in various types such as AC induction motors, synchronous motors and DC motors, each suited to different applications based on speed, torque and power requirements. Drives includes VFDs, that is variable frequency drives, and the direct current drives, play a crucial role in controlling the speed, torque, and direction of the motors. VFDs adjust the frequency and voltage supply to the motor, enabling precise speed control and energy efficiency. The DC drive regulate the speed of DC motor by adjusting the voltage and current supplied, making them suitable for application requiring constant torque across the wide speed range. Together, motors and drives form the backbone of industrial automation, enabling precise control over machinery and process while optimizing energy consumptions and enhancing productivity in the manufacturing and production environments. Their integration ensure efficient operation, reliability, and adaptability to varying operational demands within industrial setting. These are the brief introduction about the motors and drives. Deep and detailed discussion about the motors and drives we will cover on upcoming lectures. Now let's talk about the third point, that is control systems. Control systems are the fundamental to the electrical system in the industrial automation, providing intelligence and capability to manage and regulate machinery and processes with precise and efficiency. Now let's talk about the PLCs, that is programmable logic controller, are a specialized computer designed to execute programmed instructions. They control and monitor various automation processes by receiving input from the sensor, processing data and triggering outputs to control the actuators or their devices. PLCs are versatile and widely used in industrial automation due to their robustness, reliability, and flexibility in the programming diverse applications. Similarly, DCS, that is distributed control systems, are another critical component in industrial automation, particularly suitable for managing large scale process across the industrial plants or facilities. DCS system distribute control functions across the multiple controllers, enabling coordinated operations and real-time monitoring of complex processes. They integrate various subsystems and components into a unified control systems, facilitating seamless communication and centralized management of operations. DCS enhance operational efficiency, scalability, and reliability in industrial environments by providing advanced control capability and comprehensiveness monitoring of critical process. Now let's talk about the fourth point, instrumentation and measurement. They are essential components for capable precise monitoring and control process. Sensors are fundamental devices that detect and measure physical variables such as temperature, pressure, flow rate, and level within the industrial environments. They provide real-time data on process conditioning, crucial for maintaining operational efficiency and ensuring product quality. Transducers play a key role by converting the physical measurement captured by sensor into electrical signals. These signals are then transmitted to the control systems where they are processed and used in initiate control actions or provide feedback. Transducers ensure accurate and reliable transmission of data, facilitating responsive and adaptive control strategies in industrial automations. Analyzers are a specialized instrument designed to measure chemical properties or composition within process. They play a critical role in quality control and regularity compliances by the monitoring parameters such as pH level, gas concentration, or compositions of liquids. Analyzer provides a detailed insights into process chemistry, enabling operators to maintain optimal conditions and meet quality standards. together sensors, transducers and analyzers from a comprehensive unit, suits for instrumentation and measurement tools in industrial automations. They enable industries to monitor and optimize process with the precision, ensuring efficient operation, consist product quality and compliances with the regularity requirements. Now come to the eighth point, that is protective devices. Protective devices are the critical elements in the industrial automations designed to safeguard equipment, ensure operator safely and prevent damage caused by electrical fault or emergencies. Fuses and circuit breakers are the prime protection mechanism that disconnect electrical circuit in case of overloads or short circuit. Fuse protects by melting their internal element when current exceeds the safe level, cutting off the flow of electricity to prevent damage to the circuit or connected devices. Circuit breaker operate similarly but can be reset and reused, providing a more durable and flexible solution for protecting circuit from overcurrent conditions. These devices are essential for maintaining the safety and reliability of electrical systems. Now let's talk about the surge protectors. Surge protectors play a vital role in shielding electrical equipment from voltage spike and transient, which can occur due to lightning strike or switching surge. By diverting excess voltage away from the sensitive component, surge protector prevent damage and prolong the lifespan of industrial equipment. They are crucial for protecting sensitive electronics and ensuring uninterrupted operation in environments prone of power fluctuations. Now let's talk about the emergency stop buttons. They are safety devices that enable operators to quickly halt machinery in case of emergencies. Designed for immediate action, e-stop buttons are strategically placed and easily accessible, allowing for rapid intervention to stop process and prevent accidents or injuries. They are a key component of industrial safety system, providing a simple yet effective means of averting hazards and ensuring safe of personnel and equipments. Together, fuse, circuit breakers, surge protectors and e-stop buttons form a comprehensive suite of protective devices in industrial automations. These components work in convert a safeguard electrical system, protect valuable equipment and ensure the safety of well-being of operators. Now let's talk about the ninth point, that is power quality management. Power quality management is essential in industrial automation to ensure that electrical power remain stable, reliable and free from disturbance that could disturb operation or damage equipments.